All right, nice to meet you. My name is Arthur, and in today's class, I want to guide you and show you how can we create our own global state management using React only. So we'll go through an application that is using the use context API to handle all the states of this application, and we'll convert that, we'll refactor all that code to use our own library. So let's just dive into the code and into the project that we will be working on. So the first thing that I want to show you is basically the application in which we will be working. So this is basically just a simple to-do app. So the user can type anything in here. So like make a YouTube video or anything like this. Hit save, and basically we can make this as completed, delete, or anything like that. We have a sign-in process here, which the user just clicks and it makes me auto sign into my name. So that's pretty mocked. That's not the goal. It's not the goal to make the sign-in process, but really to understand the rendering process under the hood. So if I type, for example, another to-do app, you can see that it's marked here like by Arthur down here. And we also have this tasks under the top here, in which it just counts the number of tasks that we have. So that's basically it. So we will be understanding how React is handling all of those states, because we have one component here, another one here, another one there, and all of that is being communicating using the use context. But before we dive into the code, I'm just gonna let you guys a disclaimer. So a lot of this code and a lot of the lessons that I'll be teaching today is really based on this course. I really enjoy and highly recommend this course. And yeah, this application I took from this repo. I made some changes, and I will be leaving both this link for my repository and also the other one for the JStack course. Okay, so you can just go here, click code, and then git clone this project, and you will see that we have basically 3 branches. So we have the one that we'll be implementing today, which is the state manager, and we have a last one which is using Zustand. So basically, we will be taking a use context project, a project using the use context API, and we'll be refactoring that to another pattern pretty similar to Zustand. Okay, so let's just dive into the code first of all. So I'm just opening here VS Code, and I already have this project on my machine. So this is a pretty simple project, as I mentioned. So we have here just the main app, and here on the app.tsx, we have the global provider with both components that we'll be using. So we have just the app bar, which is pretty much the header that we saw. So there is the to-dos counter, which will be counting how many to-dos we have. And we have also the user menu, which is just that signing process. It's interesting to mention, and that we'll be covering in just a moment, that we have this use render counter. And what it's basically do is count how many times that component was re-rendered, so that we can understand why using use context may not be the best option in every project that you work on. Okay, but we'll cover that in just a minute. So just diving into the code right now. So we have this user render counter on all the components, just so that we can make a track of how many times we are rendering this project. Okay, so we also have this use global. So what does this user global actually do? This is actually the use context that we are using. So instead of doing that famous prop drilling process, which is just passing a prop to another component, use context is handling all of that in one single place. So in here we have the to-dos. We know if the user is logged in or logged out. I have already set my a basic like login process here, just so that we can see the login in there. We have the remove. We have all the features that a user can perform inside here, this global context. Okay, and that global context is being used in different parts of the application, and that's the sad and bad part about using context. Okay, we'll cover that in just a second. So that's pretty much a basic React application. It's just a lot of components, and we are using the use context to handle all of that data. Okay, so that's basically it. Now let's just move back to our application and see what happens when we check the DevTools. So I'll be opening my console.log here and just move myself there. I'll be just refreshing the page, and we can see that just by refreshing the page, all the components were rendered. And that's fine, that's okay, that's part of the process. But once I hit some sort of, I added more features like this, you can see that they are all being rendered. So you can see that the to-do form, which is this part, is being rendered, but also the user menu is being rendered. So also this part here is being rendered, including the sign-in process, this other component. And the same happens if I click in here. So if I click sign in, you can see that again, all the components were re-rendered. And even though that this is a small application, we cannot see any impact of this in this application. But in case you work in a really big project or a project with multiple components, that is something that can really slow down the performance of your application. So you can see that if I continue clicking, you can see that this application were rendered multiple times, even though this was not necessary. Okay, so here I have a small diagram showing what happens between when we use the context API and when we are using the Zustand type of library. So that will be working on today. So basically, when we are using the context API, we have the app, which is just our main components in which we render everything. And we have the provider, which in our case is this global provider right here. So the global provider wraps all our components in one single place. And you can see that below the global provider, below the provider, we have our other apps. So we have the app bar and we have the to-do list. So because all the informations, all the values are being stored inside the provider, if we change something on this component 2, which is not necessarily related to the to-do list, if I change a value here, then this will be changing, and because of that, the to-do list will also be re-rendered. So that is something bad about use context, is that even though we are avoiding that prop drilling process, problem which is basically sending down the props, we do have a problem regarding performance here, basically because we are sending and getting all the recent data in all different components. And that's not what we want. Actually, what would be the best scenario is that if we change this part in here, this is not related to the to-do list. So there's no reason for this to be rendered if this was changed. So you can see like how everything in this application is tied up, and we want to separate all the things into different components and manage that in isolation. So let's just move back here to our ScholarDraw, and we can see what we'll be working on in this new type of project. So instead of having everything inside that provider, that global provider, we'll be creating a store, which is basically just a JavaScript object in which in there we will be handling all the states and information. So you will see that this is pretty simple, and it's way better than just using the use context API. Of course, the use context API is great, and we can use that in different types of projects, but that's always, for example, my number one goal when it comes to handling states in different components and applications, all right? So you can see that, for example, if a component changes in the app bar, we don't want and we don't have to change the to-do list just because this other component changed. And that's the goal of today's class. So we'll be developing something new, and you'll see by the end of this class that the components will be rendering differently. So if this one changes, this one may not change, and you will see why that in a moment. Okay, so let's just dive into the code, and we will go step by step by removing and creating the store. Okay, so let's do this. Okay, so now let's just move into the code, and as I mentioned previously, we basically need to take all of that information, all of those states and functions, and move that to the store. So just moving back here to our example, the store only needs to be this big JavaScript object in which we'll be handling all our states. So the app bar, the to-do list, they will be all consuming data and changing data from the store. So in order to do that, let's just move here. I think that's a bit small. Okay, now it's better. And inside here, we're gonna just create a new folder named store. And inside here, I'll be creating a new file named create store.ts. So right now what we'll be doing is creating a function in which we'll be creating and declaring all the information that we want to have inside of that store object. So I'm just exporting a function here, name it create store. And yeah, let's just keep like this. And of course, as we follow here on the global provider that we spoke, we need to pass the initial data, the initial information. So I'll be just calling this, and here we'll be having the initial data, okay? And we'll just have inside here const name state, which is equal to that initial data. That is all having a lot of TypeScript errors in which we're gonna be solving. But let's just now do a console.log to be test, just so that we can see that on the screen. And inside here, I'll be just calling this and initiating this way. So we're just importing this directly. So every time we call this function, every time we initiate the project, we call that create store. Something else that I'll be doing, just so that we can remove any too much console.log, is just commenting this for now. So yeah, let's just check what we see in our application. So here we have the test, which is basically a console.log. So what we need to do here is basically set all the information that we need, but we can actually pass anything that we want. So here in the global context, as we saw, we can pass the user, the login, and that's all pretty changeable. We don't need to set like a type or an interface here. It's strictly saying what we can and what we cannot do. And in order to do that, we can use this TypeScript method. Like we can pass the t state, that could be literally anything, and we can say that this will be receiving the t state. So that's just what happens when, for example, you do a use state and you pass this to new or to a string. JavaScript and TypeScript already knows this is a string just because you are setting the type inside here. So that's basically what we are doing right now, okay? But in order for us to actually change that information, we need to have a function. And for that, we can just use the setState keyword, okay? And basically what the setState keyword will do is change these states. But we cannot do something like this, of course not, because we'll be sending a lot of information to this. So let's just create a small create store type of thing. So this is just gonna look like something like this. So we have a store, and that will return something to us. We're gonna see that in a minute. And I'm just gonna type a few information. So as we can see, this can be, that should be an object. So we'll be passing a username to be nothing. I'll be passing an active property to be false, for example, and also a counter. Those are all examples. You just so that we can understand this to 0, okay? And here in the store, we can actually, now that we are doing this, we need to be able to change that information. So let's suppose I want to change the username to my name. So I'll be doing a store.setState, and I want to be passing an object with the username inside here, and that will be equals to my name. We can see that we have different types of errors. Of course, we're not exporting the setState, so there's no way for us to actually get this. So we'll just be returning an object with this setState in here. So now we can see that we don't have more the error. So we have the setState, and you can see that the setState is a function that returns nothing, okay? And basically, what we need to do right now is actually pass some parameters here so we can change some sort of information. So this could be like the new state, or I'll be calling this partial state, basically because we can either pass the whole store that we just created, changing all the informations, or we can just pass one or two parameters and we want to merge it all together. So I'll be calling this a partial state. And TypeScript also has the partial keyword. So I'll be passing the partial keyword with that same t state, okay? This we can comment for now. So the only error that I'm getting is that we are not using the partial state. Okay, so let's just do it like this. Let's just take the states, and now we're gonna have the new states. So let's just do a const new states equals to that partial states. And when we merge it all together, basically what we need to do is just change that states. We'll be spreading that state to keep that information, and also spreading that new state that we are receiving so that we can merge it all together without changing the other's property. So that we can see right now that we don't have any errors, okay? But of course, we're not gonna see much information. So let's just do a console.log now, and let's just do a console.log here on the store dot. Instead of set state, let's just return this state and see what's happened. So I'm basically returning this state. We changed the information here to my name, and let's see what happens when we do call the store.setState. So let's just move back here. Let me just remove my face out of the way. Refresh. We can see that we have just an object and not much information. All right, so let's just move here to VS Code. And right now, what we need to do is actually change this information to something useful, okay? So, oh, sorry, I call it the function, not the state. Let's just move back, and we can see right now that we have the active, the counter, and the username to be all the informations that we created on the store. So the first thing that we can see is that the state is now returning the new value, and we are not changing any information. So in order for us to actually see this new username, we actually need to return a function. So I'll be creating a new function named getStates, and the getStates will basically return the states. So what will we be exporting that? So instead of getting this state that we have in memory the time that we create the store, we'll be calling the getState to get the latest changes. So by doing that, you can see that right now the username has changed to Arthur, okay? But now the getState also, the setState also needs to be able to pass a function. So as we saw here, we do have this toggleDone, the addDone, which are basically functions that are receiving parameters and returning nothing. So how do we do that here in our create store? So to do that, we need to be able to pass a partial state and a function. So instead of just passing an object, we can also pass a function. And to do that, I'll be creating a new type in here. I'll be calling this setter of n, and this setter of n will also receive a parameter. I'll be call this t, but can be literally anything. And this t will return a function, and this function will return nothing. Okay, but this function also needs to receive the previous state so that we can change it. So I can change this to previous state, and we're passing the t as well. But this will not return nothing. This would actually return the partial t. So I know this could be a little overwhelming, but just understand that this is the props that we are passing, and this is the this is the data that we'll be having inside here. So let me give you an example. So let's suppose I want to change, instead of active, I want to change to something else. So basically this will need to be a function, okay? And this function will change the information that we have there. So you can see that it already shows to me the active as here this interrogation mark, which basically says that we can pass this or not. And I can type active and change this to something else. So in order to change this to the previous information, we can actually get that from the parameter. So we can take the previous state and change that previous state to something else. So that's basically what we are doing here. We want to pass and we want to change the information based on the previous states. And the same thing could happen with counter. We can actually do the same thing for counter. So let's just move down here. And instead of the active information, I want to change the counter. So now I want to increment counter to +1, like this. So how do we enable that inside JavaScript and TypeScript? Basically, we'll be saying that we can pass a partial state or a function. And this function also needs to have a property, the parameters that we have in here. So that would be the t state. So you can see that we're basically telling JavaScript and TypeScript that we can have a function, and this function will have a parameter, and this parameter will return the partial states, which is basically this. So this is what this is doing, changing the information inside this t state. But now it's missing something. As we spoke, this can be either just a plain object, or this could be a function. So now we need to actually execute this function. So let's just move here, and we're gonna do a simple type of. We're gonna check if this partial state is a function. So we can basically do like this. And if the partial state is a function, we need to execute this function like this, passing the state. So by doing that, we are executing the function, and by executing, we are actually getting that partial state in which we want to merge it in here, because we don't want to merge a function. We want to merge what this function returns to us. So by doing that, we can do like this. And if this is not a function, then this is just the object that we want. So we can just return the partial state. And by doing that, you can see that all TypeScript errors are now gone, and we can now do some testing. So I can do a get state down here just for us to see, and I will do this a few times, and we'll see the get state after. So I'll do something like this. And now let's check down here. Let's just refresh, and we can see something interesting. We can see that Arthur here and set to true, because we changed it from false to true in here. And now in the last one, we can see that we have incremented it to 4. And the interesting part is that we have incremented it to 4 and kept that same state as we have here. So that's basically it for this part. And right now we're gonna improve this a lot into the next section. All right, but now we need to make sure that our application is reactive in case some changes happens. So how do we know if for some reason a new state or something was added or something happened? How can we make sure that we are listening to those changes and then executing those changes in the set state? So for doing that, basically what we can do is follow the observable pattern. So basically we'll have the state or the object, which is our case in the create a new object, and we'll have multiple listeners in which we'll be keeping listening if any changes happens. And if changes do happens, then we'll be notifying the state, and the state will be executing those functions, those new props. So basically the components listen to the state's changes, and multiple listeners reacts to a single source of truth. So in our case, the state here is the source of truth, is where we store the object. And in order for us to be reactive in case a change is happening, we keep multiple listeners. Those listeners will be listening to the changes that happens in our components. And when that do happen, we'll be notifying the states, and the states will then execute those functions. So let's just move into the code. I think it's easier for us to kind of get an idea. So basically it's pretty simple. I think it's doing it. It's simple than explaining it. So I would just be creating the listeners here. So listeners, this could be just an array in which we'll be pushing those listenings that are happening. And I'll be here creating a function named subscribe. So the subscribe function is just a function, of course, in which we'll be receiving exactly that listener. So we'll be receiving, instead of a listeners, one listener. And that listener is basically just a function that returns void. And right now what we need to do is actually add that listener to this listeners array. And in order to do that, I can just do a listeners dot push. But I will not be using the array method. Actually, I'll be using the states, the set. The set method is pretty much similar to the map, but it's way easier for us to deleting it, changing it. But the most important part about the set method is that we cannot add duplicated values. So if I do a listeners dot add one and then do it again, this second one will not be added. Okay, so that's why I'm choosing the new set. Okay, so the new set will also only receive functions. So I can actually type that using TypeScript in here as well. So what I can do here is just go to the listeners and do a listeners.add, passing that listener. Okay, with that, we are adding this new listener into the listeners set. And when we call the subscribe method, all we're gonna do at the end is just return a new function. And that function will just remove this listeners from the listener set. So that's all that I'll be doing. So we're just gonna be calling it and removing it from here. So by doing that, we keep it clean and we can then execute multiple times. So I will just be returning the subscribe here, and I will be actually just removing all of those console.log here. And I'll be doing istore.subscribe. And this should execute whenever a change like this happens. So I'll just be doing a console.log, passing here subscribe, change it or something like this. And when I come here to my application and do a refresh, we can see that nothing changes. So there is no console.log. And that's basically because we are not notifying those changes. So we are not actually executing that. And in order to do that, we can actually create a new function. I will call this function notify listener. And that function, listeners. And that function will basically take those listeners and do a for each. So basically for each listener, we can just take this listener and then execute it like this. And by doing that, I will just call that listeners whenever a change happens. So I'm just making sure that we are listening to it and executing when a new change happens. All right. So by doing that, when we come to our console.log and refresh, we can see that nothing happened as well. So let's just check our code one more time. So we're just executing it all. Let me move this down here. Yeah, we can see now the subscribe change it. By doing that, nothing happens because that's being that's being shown later on. So let's move it up here, and we can see that right now the subscribe do change it, and we can actually do something like a get state in here. I store dot get state, and we can see how many times that happened as well. So let me just do a counter here and change the counter to add one value. And by doing that, we can see how many times the listener executed. So we can see that the subscribe executed 4 times, which is the same amount of times that the state occurred. So that's basically it. And right now what we need to do is move most of that code out of here. So basically I can actually remove all those console.logs that store everything, and we'll be creating a new file in which we'll be actually creating that new store. Okay, so now let's do this. So now that we just cleared everything and the create store is now cleared, we can actually use that create store. So what I'll be doing right now is just creating our global store. So the same thing as we did for the context API, in which we have one global context, we can actually do the same for the store itself. So we don't need to actually have one global store. We can have multiple stores, the same way that we can have multiple context APIs. And inside here, we'll be doing something pretty much similar to the observable pattern. So what I'll be doing right now is just coming inside here, and I'll be creating this new global store. So I'll call this just a global store, which is we're gonna use the create store that we just created, of course. And since we're gonna refactor this, I can just copy this entire interface that we have with the types and so on, and we'll be using that. So, but for now, we're not gonna focus on the functions itself. Let's just move that to a place and then we move it back again. I'm just gonna set that this create store needs to have that type of interface. So that's why we made it to do like the T state here, so that we can set anything that we want. So right now, anything that the only thing that I need to set is the user and the to-dos. And just for that example, I'll be setting that to-do and as an empty array. Let me just export this. And right now we're gonna just implement that global store inside here, our user menu. So let's just move to the user menu. And the user menu, we have the use of the global, the use global for the login, logout, and for showing the user. And let's just remove this. And just a disclaimer, we are not gonna make, the code that we're doing right now is not the final code. It's just part of the code that we'll be focusing on. So the first thing that I'm gonna do is actually set the logging part. So I'll just be creating a function named logging. And that function we'll use that global store that we just created. And we're gonna set the state of the global store. And in here you can see that we actually have that user already. So I'll be setting a name equal to my name and an email equals to some random email, just so that we can see that happening. So now we have the login function, which is down here. Let's also do the logout function. So we do have the logout function down here. So just a disclaimer, once again, that's not our final code. It's just a way for us to see that actually happening. And we're gonna set this to new once again. So let's just set this to new like this. And here we go, we have the logout and the login. Now I can actually just create a use state with the user itself. So by doing that, what I'll be setting here to be equal to my initial value is actually that same global state. So using the global store now dot get state, and we're actually gonna get the user. And by doing that, we can actually see that happening. So, but if we do like this, you know that we are changing it, but we are not listening to that changes. So in order to do that, what we need to do is actually make a use effect, because the use effect will initiate our listener and make sure that we are changing it. So let's just create a use effect, and that use effect will then call it. So let's just make sure that we do the global store dot subscribe. Inside the global store dot subscribe, basically what we'll be doing is just setting the user to be equals to that get state user. So we're just gonna do it like this. So global store dot get state to be equals to that user. So every time that we change something here in the login, we get the latest changes inside here. And once that being executed, remember that the subscribe does return for us a new function, and that function will clear that state that we mentioned. So that, let me just call this unsubscribe so that we can remove that out of the way. So let me just do an unsubscribe like this. And at the end, we're just gonna be returning the unsubscribe function. Unsubscribe. I think it's like this. Yeah. Okay. So now let's see if that works or not. Let's just move back to our application. Let's just refresh it and do a sign-in, and we can see that it's looking pretty much the same. But that's not the final goal. The final goal is not to have everything inside the components. Our goal is actually to move that out of here and to that be actually in the global store. But another thing that I want to change right now is just here inside the global store. I want to make sure that we only accept objects inside here, because right now, if I do something like this, I can actually remove all of that, and I can just type a random text, and that will work. And I don't want that. I want to make sure that we only accept an object to be passed here. So I can just do something like this. So I can extend, and I'm gonna make sure that we can only pass a record, which is just an object, which has a string of a key and any as this value. So by doing that, right now, we can only allow this to be an object. So if I type, for example, something like this will not be allowed. So it's just a small enhancement for our future development. So that's it. Now let's just try to move that out of here and make sure it's inside our global store. Okay, so now in order for us to actually move all of that code, that login and logout out of that component and move it back to the global store, which is pretty much what we want to follow the same pattern as the global states, what we need to do is do something pretty similar to what Zustand actually does. So here at Zustand, you can see that when we create a store, we are actually passing it a function, and that function returns another function which can pass the set parameter to actually change the state of something inside of it, changing the state of something, of a state or any other type of information. So basically what we need to do is try to replicate that logic inside here. So in order to do that, we first of all need to change the create store parameter. So right now we cannot only pass the initial data, we have to now be able to pass that create function. So in order to do that, I'm just gonna remove this. And now we'll be calling this different. We're gonna be calling this create state. And create states will be a function in which will be execute here instead of the states. And the create states will then receive another function, which is the state method itself, which is the set state. And the set state is basically the same set state. And the parameters are pretty much the same of what we have in here. So I'll just be creating a new type. I'll be calling this set state. And the set states will also receive the t as a parameter, and we can actually paste it in here. So by doing that, we are pretty much typing and saying that we will receive a set state inside the creation of our store. And what will be returning from this? We'll be returning void, since we just be executing this function. So the set state will have this state as a parameter, and we can pass the t state to it. So this t inside here is this t state. Let me just break the lines a little bit, just so it's easier for us to see it. So now here inside this create state, we need to return something from this. So basically what we'll be returning from this, it is the t state itself. So when we call it, basically we'll be passing the set state, and that will be executing. So that's kind of the idea. We're basically just passing a create state, which is a function. This function receives the set state, which is another function, and then return the t state itself, which is the data in which we want to execute and change. So you can see that this is fine. It's actually working. We could actually move this at the bottom in case you have any ESLinks or prettier problem. But in my case, that's fair enough. It's working. So what we need to do right now is just move back to our global store, and you can see now this is totally wrong since we are just passing an object here. And now this should actually be a function. So we can actually pass and return a function here. And you can see that now this is passing. So what if we want to actually do the login and log out inside here? We can actually uncomment this just so that we need to implement it. And now, how do we actually implement this? We actually need the set states. And where do we get the set states? From here. So remember that we passed the set states as a parameter. So now we can actually use the set states inside here. And once again, that set state is also a function. And in our case, this function will take the user, and we're just gonna hard code it and set it to Arthur here. In the email, we're gonna just set it to some random email as well, like this. So it's getting an error because we actually need to set the logout. In the logout, it's pretty much the same thing. So we're just gonna do the logout here. Just gonna get hit logout. And the logout, we also have a set state. But the difference is that this set states will only return user as null, like this. So all we need to do right now is come here to the user menu. We can now remove this and then remove this as well. And we can actually get that information from inside our store. So basically what we need to do is just, we can do a const login. Let me just add a few spaces. That's going to be equals to our global store dot get state, like this, since we are returning the get state property. So let's just do like this. And here we go. We have the login, and we also have the logout function. So by doing that, we can actually, we are using those functions that we set, and now we are good to go. And if we come here once again and just refresh it, we can see that it's working pretty much the same as it was before. So now what we need to understand is how can we remove that use effect, because this is also does not seem to be right. So let's just try to remove this and we go back once again. Right, so you agree with me that all this logic shouldn't be happening inside the component. Because if we do something pretty similar in other components, like if we just copy and paste this logic and using other components, that re-rendering process will continue to happen. So the first thing that we need to do is abstract this and remove it from here and put inside our create store. And that's pretty much what Zustand does here in this use store custom hook that they have. So basically this is a custom hook in which we can pass a function, and that function will then return, for example, a new state, a new function, something that we have. So let's just implement that. The first thing that we need to do is come back here, and what I'll be doing, just removing it all, just do a Control X here, just cut it out. And inside here, our create store, what we need to do is create that our own custom hook. So I'll be just calling it a function. This function will name it use store, and this use store function will then return our t value. So I'm just gonna come down here, copy and paste, and then comment it for now. And we're gonna be exporting this use store function. So this use store function also receives the t states that needs to be passed along the way. So, and we're actually gonna have the current state, which is that state in which we'll be able to get that information. So here in the current state, we're just gonna have another function, okay? And that, sorry, this would be the selector, and the selector will then return another function, which is the current state. The current state is actually the prop, the selector is a function. So, and the current state will return the t value inside here, okay? The t value will be the parameter that needs to be passed in order for this to be executed. So it's actually the t state, and this will then return for us the t value that we actually need to have. So this is just a way for TypeScript knows what we are returning, and inside here we'll be returning the t value as well. So let's just break it down a little bit. So we have the selector, and we can actually break this into different parts. This should also be inside curly braces, and we can actually break it down to here and put it down here. So we have the selector, which is a current, which will receive a current state as a prop, and that is a function which will return the t value. Okay, so now what we need to do is actually return this value. So in order to do that, I'm gonna first of all use that same use state way. I'm gonna set this to value and set value to. And what we would do this is basically a use state, and this use state is actually gonna return a function. And guess what? The function that we'll be returning, it is the selector passing the state that we have. So that's basically what we'll be doing right now. We're just gonna be passing the state to that selector. So let me just check we can actually remove this for now. Okay, I think I'm missing parentheses or something, but that's it. And basically what we need to do is return this value down here. So let's just return the value. The state is having a few issues because we have the current state, which is basically just the selector passing the state, and we have the t states here, which is actually the t value. So basically this is the t value in which we will be passing along. All right, so now with that in mind, we can do something pretty similar. So we're gonna be using a use effect to actually perform that subscribe and unsubscribe logic. So the first thing that we're gonna do is pretty much use that same syntax. So we're gonna have the const unsubscribe, and that unsubscribe will now just subscribe. So basically we are calling that subscribe that we already have in here. And remember that subscribe needs to pass a listener, which is just a function that returns a void. So in that case, what we need to do here is just, first of all, we're gonna get the new value. So the new value is basically the selector, which is a function passing our state. So with that, we can just perform a simple check. So we can check if the value is different than the new value, in that case, we wanna update this. So we're gonna set the set value equals to new value. By doing that, we are actually updating the new value, all right? So inside here, we can actually pass the selector and the value as well. And we can just down here do the exact same process, which is unsubscribing, so we can keep it all clean, okay? So let's just format it, hit save, and by doing that, all that we did should be working fine. Let me just remove this. And now if we want to actually use the use store, we can come here, remove it all, and basically we'll set that in here. So we're gonna do a const user equals to that global store dot use store. And for this, remember that we need to pass a function. In that state, we can actually now access those values. So we can actually access the users, the login, and so on. So that's exactly the same thing that I will be doing for the login part and for the logout part. And by doing that, everything that we did should be good to go and should be working just fine. Let me just hit save. Let me just go down here. And as we can see, if we go back and refresh the page, if I hit sign in, it's working fine because we just removed part of that logic to the other components, okay? So now what we can do is actually do something way simpler. So actually what React has now available for us, it is I use hook that React developed, I think on version 16 or something, in which we can actually sync those stores. So right now we can actually just remove it all. And instead of returning this, we can just use this new property. So this is just a hook that React enable us in order to make that sync. It's just basically named use sync external store. So that's just basically gonna sync the states that we have in our application with our currently store. And you can see that it receives pretty much the arguments that we already have. So we have the subscribe, which is pretty much what we did. We have the get snapshot, the server snapshot, which is not something that we need to worry about. But basically, in order to call this, it's pretty straightforward. All we need to do is pass to here the selector, which is what we already have. And actually, I'm sorry, as we can see, we have the subscribe. So all we need to do is pass the subscribe, which we already have, and then the execution of the selector passing the states. And that's really all we need. And we can actually, I think, return this. And yeah, it's all good. With that in mind, we can just remove this. And that's just a way that React already gives to us a way to do that syncing process. So by doing that, I can just go here. You can see that we are still using that. I can just go back to our application, refresh it, clear it all, and you can see that the sign in and sign out is working perfectly with just one line of code. Okay, and that's something pretty new, you know, it's something that most developers don't know, and it's pretty simple and pretty useful, but under the hood works pretty much the same way as we just coded. So that's it. Now what we need to do is actually refactor the whole application in order to use that same hook. So let's do this. All right, so all that we need to do right now is just refactor all of this to just use our own store. So let's just dive into it and actually build it. So our create store is pretty much done. And what we need to do now is make sure that we are using all of those functions. So the first one that I'll be using is the add to do. And basically the add to do is actually a function. And as we can see here from the context that we have, the user add to do receives a title and as a string. So we're going to be passing the title as a string here, and this will have a function, and here we have the set state. And the set states will have the prep states in which we discussed it before, and then we're gonna actually be able to do to change the to-dos. So here we're actually gonna return this, so we can pass it like this. So here we have inside the to-dos the prep state dot to-dos, and we can actually just replicate the logic that we have here for the global context. So you can see that we have a concat, an ID, a title, and an offer. So let's just move here and paste it here. You can see something interesting now. We need to have access to the name, which is the logged user. So how do we make sure that we get this name from inside here? Basically, besides the set states, we're also gonna get that get state method. So we can actually just do something like this. So we'll be passing the get states dot users, right? And then dot name. So that's what we want. And in order to do that, all we need to do is here in our states, instead of just passing the set states, we are also gonna pass the get state method. And this also needs to come from here. So the get state is also a function, and that function will just return a tstate. So that's it. That's all we need to access the get state, which is the most recent changed value. So now one more thing that we can do is that instead of sending all of that information, actually all we need to do is just return the use store. We are not using the subscribe anymore. So let's just return the use store down here. Now with that, all we can do as well, we can actually change this to use global store 2. So that's just a more better name for us to set the store. And in here, we can just set it to be our use global store. So that's just a way better syntax to work on. Now let's just undo the other one. So that's the toggle done feature. Let's down here, add a comma, add the toggle down. This one will actually be receiving an ID. So from here in the global context, we can see that we have a to-do ID, which is just a number. So we're gonna pass that as well. We can come here and pass it, and we're just gonna set that state, and we're gonna get the prev state as well. And we're gonna just perform pretty much the same logic that we have. So we have the to-dos, and we can just copy and paste what we have here. So we have the prev state dot map, and we can just paste the logic down here. And we can do prev state dot to-dos, and that's it. That's it, and here we go. The last one is just the remove to do. We can just go down here, add a comma, do pretty much the same thing as we did. So just a to do ID, which is a number, and we're just gonna return a function, and that function is just a set state. I'm just gonna copy and paste this, and instead of the to do's here, what we can do is just do this prev filter and filter it based on the ID. So we can just do it like this. So prev state dot to do's dot filter to do, removing it. So that's it. So we just created all the features and functions that we need for this application to actually work. So all we need to do, we can actually just remove this global context. Let's just remove this. So we force us to actually use that. So let's just move here. And now what we need to do is we are gonna set each one its own feature. So we have the use global store, we have the states, and for each one we take the state, for this case state.todos. We can remove this, and we can do now here something different. We can just take the to-dos. Now we gotta take the toggle to-do. So let's just move down here, copy this one, toggle and toggle, and then we just can do the same thing for the remove. We can just do it here, and here we go. That's just perfect. That's just what we want. We're gonna do pretty much the same thing for this one. So we can do a const to-dos equals use global store and take that to-do. So state.todos, right? And lastly, we have this one, which is just a function. So we're gonna use the add to-do feature as well. So here we can get the use global store state and get the state.add to-do. And that's it. Like, we only have the app bar, and the app bar, yeah, uses the to-dos counter. So that's all we need. And right now we can just make this a fragment. And now we're really using our own store. We are not depending anymore on any use context or anything like that. So once I come back here, I can open my inspect, check the console log. Let's just clear everything. I have already enabled this back again. So in case you are doing it with me, this is probably comment. So just some comments like this. Let's just make sure we have saved everything. And yeah, it's all saved Let's just move here and let's just clear the whole thing. Let's see if that works or not. So if I do assigning, you can see that the user menu, let's just clear it all again. Okay, just refresh it. So you can see that everything rendered at least one time. If I add a title like video, you can see that the to-do list in the user menu rendered 2 times, but the to-do counter rendered 3 times. Okay, let's just keep changing the title. So title, title, and title. And we can see that even though these changed like 6 times, the signing process has not changed. So let's just do a signing. You can see that the user menu, which is basically this feature up here, only rendered 3 times, while the other ones rendered 6 times. We can actually see that the to-do form also rendered a few more times than necessary. So let's also do that. In order to prevent this to be rendering too many times, we can go here to the to-do form. So basically the to-do form is just a way for us to type and add the values. So that doesn't need to be rendered many times. So the to-do form is actually being rendered inside here. So this will also actually be rendered every time the to-do is changed. And in order to fix this, we can actually memorize this function. So we can have a memo here, and this can be a to-do form component. And all we need to do right now is, instead of exporting this, we can export. So you can just do like this. We have the to-do form, and then we do just a memo of the to-do form component, just like this. So by doing that, we have exported a function. Oh, sorry, we gotta export a const to-do, and here we go. And now we have the memorized version of to-do form. So if I come back here, refresh it, you can see that everything rendered at least once. But once I change it, you can see that only the list and the counter changed, but not the form. So that's it. That's basically the application. You can see that it's not like a super huge difference that we have in this small application, but once that scales and grows, those same principles are really useful and can be handled into different scenarios. So that's it. I hope you really liked this project, and I hope that you also have learned something new, something that you can show, and something that you can apply on your own projects. And that's it. And just to make sure that if you want to actually use Zustand on this project, it's pretty simple. All you need to do is just install Zustand, and you can just rename instead of using the create store, you can use the create store from Zustand itself, and it will all work the same. So if you actually want to dive into the documentation, I highly recommend you to do that. But you will see that even though that the Zustand has more features, of course, it's pretty much that same code under the hood for at least those basic implementations. So that's it. I hope you like it, and I hope I can see you in the next one, and have a good one. See you in the next video.